So here in the Midwest, we don't really have a lot of natural disasters, but down south, they're kind of a more recurring thing. Over this last fall, with Hurricane Irma and Hurricane Harvey, Dell EMC was getting a lot of phone calls about helping these small businesses set up disaster recovery solutions. Dell EMC at the time didn't have the time nor resources available to them to be able to actually help all the small businesses. So it begs to ask the question, if your business was to lose all of your data, would you be able to bring it back up? If there was a major disaster and your company was unable to operate for a significant amount of time, would you be prepared for that? Well, that's where we came in. We were tasked with exploring disaster recovery solutions for Dell EMC for our fall 2017 capstone project. We call ourselves Data Saviors. My name is Jacob Erickson. I was the team lead and head storage engineer.
I'm Glade. I was the lead virtualization engineer.
I'm Kubesh. I was the lead network engineer.
I'm Jesse Lee. I'm the lead server administrator.
So first things first, we'd like to thank our sponsor, Dell EMC. They donated $500,000 worth of equipment to our program. We really appreciate that because that's what we got to work on all semester. This is actually a picture of them installing it into our lab. We really appreciate that donation because we actually got to work on this $500,000 worth of equipment, which was a lot of fun. And then we'd like to give a special thank you to Jake Medford, Steve Holm, and Mike Madsen. They helped us a lot this semester, meeting up with us every Friday to answer any questions, having impromptu WebEx sessions with us to make sure that we were getting stuff accomplished when we needed to, and answering our emails at 10 o'clock at night just to make sure we're keeping going. So we really appreciate that. Thank you, guys. So, on to our agenda. First, we're going to be talking about our problem statement, going over what our testing environment was, talking about the 3 solutions we were tasked with testing, do a live demonstration, have a conclusion, and then a Q&A session.
All right, so problem statement. Dell EMC has tasked our team to find a disaster recovery solution for small businesses. The solution should be cost-effective, easy to manage, and have their services up in the required time frame. And then our deliverables from Dell EMC was to test 3 different solutions, have this presentation here, our live demo later in the presentation, and our white paper.
So why disaster recovery solution? Well, as you can probably guess, that we mostly picked the disaster recovery because it's a very popular industry right now in the wake of Hurricane Harvey and Hurricane Irma. As small businesses in the path of destruction of those hurricanes in the days leading up to it, we're calling Dell EMC, asking to help them implement a disaster recovery solution in time to restore their vital services and their vital data. This points to a larger problem within small businesses, and that many of them are moving their resources onto their IT infrastructure in order to become more efficient, and this is making these systems very critical to keep them up. We found in our research that 1 minute of downtime is about an $8,000 loss on average. And many small businesses are vulnerable because they do not have the time or resources to invest in a disaster recovery solution and may not necessarily be higher on their priority list. So they're less likely to implement them and thus more likely to be without a solution when it comes time to face a storm or a disaster, making a disaster recovery solution exploration very important.
All right, to recap, our objective is to find a disaster recovery solution for small businesses with automated backup, ease of management, it is affordable, and it meets the time requirements of our recovery time objective and our recovery point objective. So what is RTO and RPO? On the right side of this image, we do have RTO, recovery time objective, and it is the time that it takes for your services to come back up after a disaster happens. And for this project specifically, the time requirement was no longer than 10 minutes. And this is a crucial business factor because this is where the average amount of money lost per minute comes in. And then on the left side of this image, we do have RPO, recovery point objective. It is the last checkpoint of data saved, so when a disaster happens, you won't lose any data later than that checkpoint. And for the time requirement for this recovery point objective was 20 minutes. And then to reiterate, RTO, recovery time objective, shouldn't exceed 10 minutes. RPO, recovery point objective, shouldn't be later than 20 minutes. And then just a side note, these are just requirements for the project and for small businesses, and the requirement could change depending on the company.
So our testing environment is comprised of equipment donated to the program by Dell EMC. To start, we have the Dell 7020 storage centers. We have one for the production side up here, one for the disaster recovery side down there. They hold all the storage for our devices, mainly the two servers we have on the production and disaster recovery environments. We are using the Dell PowerEdge R630 servers. They hold all of our virtual machines that Connor will go over later, and mainly while running those, provide access to the internet for both sites. So the switches that they use to connect to the storage are two Dell 4048 switches and two Brocade 6505 for the production side. So here we have our production topology. This is just our production side. We have our storage down here, which connect to the switches, which then bring them to the servers, and the servers will run the VMs, connect to the management switch out to the router and the internet.
So virtualization is a very important part of our project. Basically, in essence, instead of having multiple machines each running one server, we have one larger machine running all of those servers virtually at once. This allows us to save a lot of money by having less machines in the environment, and it also stores these servers as files along with their storage, which makes them very easy to add, manage, and move around. It's a very important part of our project. As for the virtual machines that are running in this company's environment, we have two Windows Active Directory servers for user management and IP address management. We have two Windows file share servers with shared storage. That means there's a disk that's connected to both VMs. This is as a central location for employees to store their files. We have two Windows SQL servers also with shared storage. This is for database management. It's very important for programmers and any applications running in the environment. And we also have one Linux web server hosting the company website. As for how these are laid out in our full topology, Houston representing our production site, Chicago representing our disaster recovery site, we have our virtual machines split between the two servers that Derek mentioned earlier. This is so that if one machine goes down, the other can stay up and provide these services to employees. And on the disaster recovery site, we're split over a simulated internet connection. We have almost an exact replica of the hardware on the main site, two servers, one storage center, to simplify disaster recovery management and operations. Now, essentially, our goal with this environment is to take all of these virtual machines and move them over to the disaster recovery site as quickly as possible, as seamlessly as possible, to allow business operations to maintain operation and provide services for employees. As for the solutions that we chose to do that, Jacob's going to go into those now.
So these are the three solutions that we went with. We went with VMware Site Recovery Manager, also known as SRM, with vSphere Replication. Our second solution was also SRM, but this time with Dell Replication. And then our final solution was VMware Metro Storage Cluster and Dell Live Volume. So how each of these solutions work are, we have our main site and our disaster recovery site, as Connor stated. One of the parts of the solution was in charge of replicating or copying the VMs and storage over from the main site to the disaster recovery side. And the other part of the solution is for bringing back up the disaster recovery side when the disaster hits. So what should happen is when the main site goes down after the disaster, the recovery site should come up automatically with the VMs, losing no more than 20 minutes of data previous to the disaster. So our first solution is VMware Site Recovery Manager and vSphere Replication. For this, vSphere Replication is what was used to replicate the VMs and storage from the main site to the disaster recovery side, and VMware Site Recovery Manager is what was used to bring back up the disaster recovery side after the disaster. How vSphere Replication works is it takes it works replicating at a VM level. So the VMs are replicated every 20 minutes over to the disaster recovery side. The issue with this solution, though, is, as Connor mentioned earlier, we have those VMs that have the shared storage. With vSphere Replication, the shared storage doesn't work when copying over to the second side. So what will happen is the VMs will have their shared storage on the main site, but when replicated over to the secondary site, the VMs will actually only take the storage that they see, which means there will be two separate storage for each of those VMs on the disaster recovery side. This creates an issue when we're trying to bring back up the main site after the disaster and kind of breaks the solution as a whole. So some good and bads about this. The good are it's easy to configure. vSphere replication and SRM have wizards enabled on them, so it's very easy to set up, just an easy process to go through. The disaster recovery plan in SRM, Connor will be talking about that in a little while, but it's really easy to read and really easy to just go through when the disaster hits. It also dynamically reassigns the IP addresses. So once the disaster hits, you know that everything has come back up on the disaster side because the IP addresses have changed for each of those VMs. The bad, it doesn't work with clustered storage, as I mentioned earlier, which defeats the purpose of having those shared storage, really. The full syncs are unreliable with vSphere replication, and they're also very inconsistent with their copy times, which oftentimes will break the RPO and will not be replicated often enough or to the degree needed to meet that 20-minute RPO.
As for our second solution, we decided to stick with VMware Site Recovery Manager, a carryover from our first solution, but we instead opted to go this time with Dell replication. Now this second solution works very similarly to our first solution. It's still making backups every 20 minutes, and SRM is still there to bring everything up when the disaster hits. The main difference is that instead of copying the VMs on the compute level, it's copying on the storage level, which means that it's taking the storage individually as well as everything contained inside of it and moving that over to the disaster recovery side. This allows for a much more robust solution that allows us to maintain the shared disks as they're attached to both machines at once, and which solves the major problem with our previous solution, while allowing us to continue to use Site Recovery Manager. Now, one of my favorite things about it is how well it works. Here's an example of a recovery plan within SRM. It's very easy to follow. The steps that it follows are numbered here. As it executes a plan, you can see progress bars on each of the different steps. It'll show failure results. It'll show any failure messages if anything goes wrong, and it'll show the priority of the VM, so you can prioritize which ones you want to start up first because they may be more critical. This is one of the best things about this solution is that it's very easy to visualize an exact disaster recovery plan so you know what you're getting into. And they are editable as well. And pairing this with the fact that it dynamically reassigns IP addresses when it fails over, and the fact that with Dell replication, synchronization is much faster, much more reliable, and much more consistent than our previous solution. Some of the downsides include that it is not as flexible with storage. You obviously need two Dell products to work with Dell replication. It does require a little bit more setup to get it working. However, one of the other major things that we found is that it is not automated. In the event of a disaster, you still need an administrator to be notified of the disaster, log in, and hit the big red button to fail everything over, which may be fine for your situation, but we wanted to see if we could get those times even lower with an automatic solution, which Derek's going to go into now.
So our last solution, we used Metro Stretch Cluster with Dell Live Volume. Metro Stretch Cluster is a bit different from SRM, where it's more high availability than disaster recovery. So rather than wait for approval to move everything over, it just wants to kick over the VMs to the next available site, which in this case was a disaster recovery site. Dell Live Volume is a bit different from the other replication services, where it adds a layer on top of it. As well as replicating from site to site, both sites are working together to present one storage device to the servers on both the disaster recovery site and the production site. So as far as they're concerned, they are using the exact same device. And if one side were to fail, the other one would take over all responsibilities. The good with this is there is no interaction needed to start. You do not have to wait for an admin approval to just go in and push the button to make it happen. It just kicks over to the other site automatically. It's much faster that way because for the other solutions. It also doesn't go through all the checks that SRM does before it starts turning on the VMs. It just turns them on. And with this, we are actually able to get fully automatic failover. The bad is it is a little more strict with network requirements. For our statement of work, we had to have a delay of about 20 milliseconds between the sites. For this to even be set up, we actually had to cut it in half to about 10 milliseconds or less. We had Dell EMC's approval to do so, but you have to invest in a better connection to your disaster recovery site. More complicated to set up, and it is not specifically designed for disaster recovery. As Connor was saying, SRM gives you all of these features, lets you automatically change your IP addresses. With this one, we basically had to mirror our entire production site over onto the other site because it doesn't do any of those changes. So timing-wise, our first solution, that's SRM with vSphere replication, we're able to test it at about 8 minutes and 43 seconds. Solution 2 was we had continued failures, but with the failures, we were actually able to predict an estimated downtime of about 6 minutes and 32 seconds. And with solution 3, we have consistently been getting about 2 minutes and 43 seconds, maybe a little over, maybe a little less, depending on the situation. And with that, we will be moving to our live demo. Connor will take over while I switch hosts.
So because our equipment is big and heavy and expensive in a rack, we can't exactly move everything down here, unfortunately, to test here for you. So we have our good friend, Hurricane Pierce, waiting up in the wings, waiting to wreak havoc on our network by simulating an absolute worst case disaster, which is pulling the plug on our production site and having everything hopefully automatically fail over to the other site. How you doing, Pierce? He's doing good. He's doing good. So if you look over here, Jesse has brought up a timer with a money counter on the side. This is going to be very important for timing exactly how long everything is going to take to come back up once he pulls the plug. You ready? All right. Going to do a countdown before you start the timer. 3, 2, 1, hurricane. And the power's down.
Okay, as you can see, we're actually losing connection to our host devices here. Over here, we are pinging our Active Directory server. This is our web server, Linux, and this is our file share cluster. Over here is our SQL server. This is just a diagram of our Houston to Chicago site. You can click this because now it's down. Whenever I get to it. So what happened over here is we have up here at the top 4 our hosts. Down the bottom 2 are our disaster recovery, and the top 2 are our production site. This might not update fast enough to show that these have gone down as VMs, but the hosts have gone down and are currently failing over to the disaster recovery site.
Essentially, what we're going to be doing is we're using these ping tests to see when services will be restored. Once all of these pings start resolving, then we'll stop the timer and see exactly how much time it has been down and how much money the company has lost. Currently, what's happening on a technical level is that once the hosts on the main site went down, as you can see, they just updated. It's taking our VMs and it's finding hosts that it can start it up on, which is going to be our disaster recovery site, and it's going to bring everything back up on the failover site. And there's our web server that's coming up right now.
We may have tweaked some of the settings on the SQL and file server. It may be faster than normal. We thought maybe we could try to speed it up a little bit.
In our testing, we found a consistent 2 minutes and 43 second uptime. And there's our clusters both coming back up. Now we're just waiting on our Active Directory servers to come back up. I can see what time we're about. That was about 1 minute 45 seconds for all 3 of those services to come back up. The main ones that your site is going to be relying on. Just waiting on our Active Directory servers to come up as we speak. They're typically the slowest.
Especially this one, it likes to take its time.
It sure does. Ahead of time, we've been running tests on our file server, on our SQL servers to create an entry once a minute so that we can test RPO once everything is done. And that's time. How long was it? We have 2 minutes and 23 seconds total downtime for your network for everything to come back up after a total site failure. Now that was completely automatic. None of us were doing anything. Hurricane Pierce has his job done. So that was a fully automatic solution. 2 minutes and 23 seconds, and your company has lost about $19,000. Well, when you compare this to the previous solutions, which A, costs more. SRM does cost $8,000 for a 3-year license, and are at least 3 times as slow. You consider the cost savings that you've had by having this solution come back up in a staggering 2 minutes and 23 seconds.
So with this, we'll be concluding our live demo. I'll switch it back to the slideshow.
All right, so in conclusion, due to the recent disasters, our team was tasked to find a disaster recovery solution for small businesses with a automated backup, ease of management, it is affordable, and it met the time requirements of our RTO and RPO. We chose our third solution, Dell Live Volume and Metro Storage Cluster, because it had the least amount of user intervention, and it is free with licensing, and it had the fastest recovery time, as you can see there. So let's all remember that time is money. And speaking of time, we did spend about 656 hours on this project together with the help and guidance of our Dell sponsors. And what I learned from this project is that when I grow up, I want to be just like them. And aside from that, I did learn a lot about this project and how a disaster recovery solution actually works and how it is implemented.
So one of the big things that I learned about this is that, I mean, we all work with technology. We all know that technology is great when it works and absolutely the most awful thing ever when it doesn't. When we had a lot of times in this project where things abjectly did not work or they failed on us, where we couldn't get it to work. But what I learned, most importantly, is that every failure is an opportunity to understand the system. So every time something failed, we had a chance to dig deeper and find out exactly how it works, to find out what the problem was, and to be able to fix it and make it more efficient in the future. So every failure was an opportunity to learn. Even with our solutions that didn't work, that we were able to do very limited testing on, we still got some valuable data out of that to provide to Dell EMC and to present to all of you here today.
Something I took away from it was a lot of the value of communication. We spent 656 hours on this project, and I don't think a day went by where I did not know what needed to be done to help move the project forward or what the other group members have done to contribute as well. It extends even further to that. Whenever we ran into issues, we were quickly able to establish communication with our sponsors at Dell EMC. In most cases, either resolve the issue the next day, or sometimes we were lucky enough to get it done the same day, which I really appreciate. It did save us a lot of time.
Over the last 4 years here, we haven't really got to touch anything other than Cisco products, so it's really nice to be able to get different equipment, mostly the Dell switches and Dell servers and the storage, network storage, which I personally haven't been able to touch over the 4.5 years I've been here. So it's really nice being able to actually get the opportunity to work with network storage. I really hope I can bring it into my work life after I graduate here tomorrow. So we'd like to thank you all for coming here today to see our presentation. We really appreciate the Dell's donation of $500,000 worth of equipment and the three guys' donation of time to us. As you can tell, we're very grateful that you were able to help us throughout this entire project, and we really appreciate it. So thank you all again for coming today. If there's any questions, feel free to ask us.
Did you have an opportunity to look at using VApps within your vSphere structure?
I don't think we specifically looked at that technology, since what we were wanting is we want to simulate an actual, like a full site failover. We did have Microsoft failover clustering within the applications for the file server and the SQL server, which would provide application level redundancy, so that any one of those, if any of them goes down, then you can still have that application available. But we had to work on a lower level, as we found with our first solution. We had to work on a lower level to make sure that everything was going to fail over successfully.
Sure, the VApps kind of allows you to pick and choose which VMs come online first. Mm-hmm. So I don't know if you had was there any concern on which VMs needed to be up and running first before the other ones in order for potential applications?
Yeah, that's definitely something. Did you want to take this?
No,
that's definitely something you could utilize with Metro storage clusters. The prioritization of VMs within that. We didn't necessarily have the time to explore that ourselves, but that's definitely an option. And of course, if you didn't have the network capabilities, you could go with our second solution, which we would also recommend as a very capable solution, that you can prioritize within VMware which VMs are going to start up first.
And that would be with SRM. You can change the priority of the VMs, so if something's going to take longer, you might want to start that one up first, or if the start it up last, if it's the least priority.
Good question.
A couple questions, one technical and one just elaboration. So how did you guys collaborate well. But it seems like you guys know what you're doing on a daily basis, so I can track work and stuff like that and progress. And two, how did you guys get down? You talk about latency being the issue. How did you reduce your latency overall?
I can answer the latency one first.
Yeah.
The whole network itself, we had a latency of about 1 millisecond, so our issue was actually making it 20 milliseconds, which we had to do by putting a filter, I think it was a filter on pfSense, which was our router, which would actually force the delay of about 20 milliseconds or more.
And for the communication one, we had a Facebook chat. We just were making sure we constantly were checking that. If we got emails, we'd make sure to respond to Facebook first, figure out who we wanted to respond to it, and make sure everybody was on the same page at any point in time. So really, it was just using Facebook, yeah.
It also helped that we were also very paranoid about this project, and that we all wanted to be as good as possible, so that we happened to meet very often within our capstone room where our rack is currently sitting, and try to work. And we had a lot of opportunities to work everything out in person with whoever happened to be there at the time.
Yeah.
What other solutions did you consider? Right? These were your top 3 choices. What else did you look at?
We looked at I can take
Yeah,
it.
go for it.
We looked at some other solutions. We looked at like some third-party VM solutions at the beginning, such as Veeam availability, which is another thing that fails VMs over. But we found that with testing vSphere replication, that our options were going to be more limited than that because of the fact that we had shared storage. When we realized that vSphere replication wouldn't work, we kind of also had the realization that any VM replication application wouldn't work in the way that we wanted to for this environment.
I just have a comment.
Mm-hmm.
I really like the counter with the money going. A few years ago, we did a similar project called the $1 Million Outage, that we had a TV sitting in the corner of the room with a dollar value spinning as they were sitting up there trying to bring things up. And I think it's a really good showpiece for presentation. I mean, and that's something that plays into this. It's not always about the technical. So you guys were presenting back to us what our options were. And a large portion of that as a business is selling it. How do you sell that solution? And having that counter go in the corner was pretty cool.
That was Jesse's find. That was absolutely fantastic find.
Oh yeah. The big thing with that was bringing everything back up. There's not a lot to watch. You're watching a bunch of ping tests. It's kind of boring. We wanted to bring something more exciting into it to make it a real world thing, less than here's some ping tests. They went down. Oh no, it's broken. Oh, they came back up. We fixed it. Yeah.
Question for you guys, kind of along that same business line. Those 3 different options you looked at, was there a price difference? I mean, was one option, $1 million, and one was $2,000?
I can take this one.
All right.
So SRM is the only thing that you'd actually have to pay for outside of vSphere and Dell Storage Manager. Live Volume and Dell Replication are both included in those applications. So if you have Dell Storage, you already have Dell Storage Manager, so those weren't extra prices.
Sure.
vSphere Replication was $8,000, I believe. Not vSphere Replication. SRM was $8,000 on top of the cost of vSphere and then Dell Storage Manager.
Yeah, we kind of went in with the assumption that this is their existing environment, so they're already going. So in order to run the machines they want, they already have the licenses necessary to be able to run that. And then in our last solution, Metro Storage Cluster, entirely utilizes features that come with vSphere, most licenses above the very basic one, as well as when you purchase a very expensive Dell EMC SAN.
You guys do any bandwidth monitoring while this was happening, and project that in terms of cost overall, like a live internet connection between sites?
I can take that.
Go ahead.
Most of the bandwidth utilization was actually in the minutes leading up to the failover, since everything is being replicated ahead of time over the link, and there are certain features like replication deduplication is a feature that you can able to shrink the size of the updates and use compression to make it much more efficient on your bandwidth. But We did some basic bandwidth monitoring within our router. We have pfSense. Do you want me to go to that right now, or?
We use pfSense to do some monitoring of the network, but in the testing, we didn't check it that thoroughly for cost analysis or anything really. We're happy it was working.
As far as we saw the bandwidth utilization, even when replication, even when it's 20 minutes at a time, was still very low, and this obviously might change with a heavier enterprise workload if you're replicating more things over. But we still feel that it's very efficient as far as bandwidth utilization.
I had a question about round trip time. So this third option, was it a 10 millisecond round trip time requirement? Realistically, yeah. I mean, did you put any thought into realistically? Would this be a decent solution for a small business? I mean, with the disaster recovery between two data centers,
Right.
Usually you want at least 20 to 30 miles between the data centers. Is it realistic?
I would know this one offhand, actually. I was more focused on getting it up.
I think it's a cool solution. I'm just curious.
Yeah. That's a valid question for sure.
That was one thing that when Dell decided to let us actually reduce that, it was something we were supposed to mention for sure. It is a little bit, it would be a business expense to get that connection upgraded like that. I think Derek mentioned that in the presentation. I guess we didn't really analyze the business cost with it because I wouldn't really know how to go about doing a business.
Yeah. Well, I'm not a storage guy. I'm just curious. Yeah.
Right. What we can say for sure is that it's definitely a possibility that Metro Storage Cluster may not necessarily be feasible for a small business, and in that case, we would recommend our second solution with SRM. Unfortunately, we wish we could bring better data, but we were limited on time and resources coming up here to the presentation today. But we found that it's still a very, very effective solution for bringing everything back up. And if we had used our time just a little bit more efficiently, we probably would have found similar results to what we found our calculated minimum time that it would take to come up, which is about 6 minutes. So we'd still definitely recommend that.
Any other questions? No? Well, thank you again for being here today. We've been talking about this $500,000 donation that Dell made to us pretty much our entire presentation because that's what we got to work on all semester. If anybody would like to come see that storage rack after this presentation, you can feel free to come up with us to see the lab and see what we've been working on all semester. We'd also like to invite you to a happy hour at the Silver Dollar at 2:15 to learn anything else. If you'd like to learn more about the CNIT program or the capstone projects as a whole, feel free to come. We'll be there. We'll be willing to answer your questions. So feel free to come by at 2:15.
Yeah, and some of the students graduate tomorrow, and they are looking for jobs. So you are usually employers go to talk to them. Yeah, still interview. Great job. Thank you.
Thank you.